I welcome you guys to a tutorial video on how to use a digital multimeter. So of course a digital multimeter looks something like this. So for most of you who love playing with electricity, I'm sure at one point or the other you have wanted to use a digital multimeter. And for most of you that say I probably don't need it, well, it is because you never had it and you really can't miss something that you never really had. But overall, you see that when you deal with electricity, you always want to use a digital multimeter because it makes work very easy for you. Let me give you an example. Suppose you've got these many mesh of wires and you want to find out which particular wire is not working or maybe has been disconnected. You can simply use something like this to get that thing done within seconds rather than using the natural way of testing each and every wire, where you remove it, plugging another wire and stuff like that. So without further ado, let me give you the basics to using a digital multimeter. So I deliberately disconnected the probes so that I can also show you where you put the probes and why you place where you're placing. So for a start, so basically these are the ports that a standard digital multimeter has. 4 ports. What do the 4 ports mean? Well, this one, as you can see, there's a symbol right there for V/ohm. So there it shows that when you use this probe, you're basically trying to test for the voltage or the resistor. And then this one, this simply means milliamperes. And of course, when you look at amperes, these are basically units for current. So this port has something to do with the current. But millipart, which is simply 10 to the power -3, shows that you're dealing with extremely low amounts of current. Current way less than 1. On the other hand, we have got this 20 amperes, which simply shows that it's a port that you use to measure currents that are above 20 amps. On the other hand, when you look at this 20A, it simply means 20 amperes. So this is a port where you use to measure currents that are high, but not higher than 20 amperes. As you can see there, it is even written max 20 amperes. In other words, if you connect to this probe and then you measure currents that are extremely higher than 20 amperes, what simply it means is that you will end up burning the fuse in this circuit. It won't necessarily damage the entire multimeter, but it means you will not be able to use this port anymore. So what are the 3 things? That you measure on a digital multimeter? Well, basically I'm going to teach you on how to measure the resistor, the voltage and the current. That is both in AC and DC type of currents. AC simply meaning alternating current, and DC of course simply meaning direct current. So first and foremost, how do we connect the multimeter? So like I said earlier on, this is for voltage / resistor, current very small milliamperes, current that is large but not larger than 20 amperes. So this, however, is a port for the common. This is where you place your black probe. It should always be there. So I'll deliberately start by testing for the current, and the reason why I'm going to do that is because current is often neglected as part of the test on most YouTube videos. I don't know the reason, but testing for current is actually one of the simplest things. The only thing you need to know is that for current, you always test in series. Things such as voltage, the resistor and other things you always test in parallel, but for current specifically you test in series. So to help us see the amount of current that a device is consuming, we're going to use a standard USB charger. As you can see it there now, this one is connected to a USB cable, and this USB cable has got a long cord all the way to this part here, where I disconnected it, where I've got the red cable and the black cable. So the idea is, since this is connected on a power source and I have the red cable here, it means if I connect this there, I should have the light on as it is on there. So now I'll disconnect the red cable. Pay attention, I'm disconnecting the red cable. I could also disconnect the black cable and leave the red cable there. It simply means that my current will have a negative, showing me that I've not connected it the right way. Because obviously you can't have a negative current. It's simply a positive current, and the negative is just basically for your direction. So I've disconnected the red cable, and what I'm going to do now is connect the red probe towards the red cable, and then I'll connect this black probe towards where the red cable needed to connect. Now observe what happens to the multimeter. See that? As the light turned on, the multimeter has a reading of what? 1.31 amps. So in other words, a standard USB charger will produce an output of about 1.31 amps. Now the question that some of you might be having is, why did I decide to use this port as opposed to that port? Well, it is often advisable that you use a bigger value rating as opposed to the smallest value rating when you're measuring, especially if you're not so sure of the output. So in this case, I had an idea that this would produce something like 1.something amp. But in a situation where you don't know, you'd rather start with the maximum and then keep on reducing. So I started with the maximum 20 amps and refuted from using the milliamp, which is 10 to the power negative 3, which is 0.001 amperes. I refuted from using this one because it showed just little current there. So there you are. That's how you basically measure the current. And maybe one more thing to point out is, if you've observed here, I basically tuned the multimeter to the part that shows the current in white with dotted lines on top as opposed to this wave-like line. And why is that? Can you give a guess? Yes, it is because we're dealing with direct current. Whenever current passes through some sort of charger, often the output is always the direct current. Now if I was measuring current directly from this power source, it means I would have placed it on the alternating current source. So there it is. That's how you basically measure the current that something like this LED light bulb is consuming. Let's go to the next one. So now the next thing that we are going to measure is something called the voltage. So to measure the voltage, the first thing that you have to do is, of course, disconnect this probe and connect it where you have a V sign. That shows that you are now planning on measuring the voltage. Now I'm going to measure the voltage that is passing through this USB cord, of course, from the output there. So I might as well disconnect this from there and just have these two cables. This is directly coming from the power source here, from a standard USB charger. Now where am I going to place this arrow? So now I'm going to place this arrow somewhere in this greenish region where it is showing the voltage with dotted lines, because anything that comes from the charger, remember, is always direct current. So I'm going to place it on the number 20. Could you guess why? Well, if you guessed correctly, it is because, you know, when I look at this small charger and I'm able to hold these two cables without being electrocuted, it just simply shows that you have got a considerably low amount of voltage. Probably not so low as 2 volts, but something low. So the only thing you have to do with voltage, it's really you are more likely to get extremely electrocuted when you use something like this as your resistor, because it's really something small. Now of course, depending on how long this is, it will affect how much resistor it has, but as it is something like 0.8. So really that's it about the resistor. Maybe the last thing to point out now is the continuity test. And really, when we talk about the continuity test, what we are simply trying to do is test to see if there's continuousness in a circuit. Really, continuousness just simply means if you want to test if the cable has been disconnected or it is connected all throughout. So for example, if I was again to target just the red side of this cable, I want to see if this red side is completely connected nicely to the other red side. I'll simply place my multimeter on this symbol right there. That is the continuity symbol. I'm sure you can see it. It's some sort of ringer type of thing that is written there. Yeah, that is the symbol where you place for continuity. And there's really a diode, a funny looking diode, quite. So that's the other symbol that you can check out. Yeah, so like I said, continuity is simply trying to check if the cable is connected throughout. Now if the cable is connected throughout, it normally gives a buzzing, beeping sound from there, and of course you also see the LED light turning there. So this red cable is okay. So if I connect this to the other red side, I should expect to get, yeah, that simply means that this is connected. So what basically happens is that the multimeter basically sends some sort of low current to see if it will be able to tap it on both ends of a cable. So if this wire was not connected properly, it was somehow disconnected, it will be almost like probing this other probe in thin air, which will simply mean that this cable has somehow been disconnected. So really, that was it today about understanding the basics of a digital multimeter. Now of course, if you have observed, I've used more of direct current. I would make another video to show how you can test all the things that we tested, but this time using alternating current. So please subscribe to my channel, and of course turn on the notifications so that of course you can be notified whenever I have a new video. And of course, for some of you who have got personal questions, you can still type them in the comment section, and then I can produce a video for that. And then there's a link attached to this video on how to test if a transistor is working. I'll continue uploading videos like that so that you can in itself learn how to use this multimeter to determine if different types of components in on an integrated circuit are working. For example, how do you tell if a capacitor is dead? Because sometimes it won't necessarily be blown out where you can see it with your eyes. Sometimes it will just be intact and you'll not be able to tell. So I'll make those kinds of interesting videos, and you can only know about them when you subscribe to my channel. So until next time, goodbye.